Welcome all. I hope you're all having a good conference. So I know I have the next 20 minutes to hopefully walk you through something that you can sort of like take back home and is probably insightful. So let's just kick it off from here. So let's take a walk back through the memory lane, right? So imagine you're in the market, you want to buy a sofa or a sectional, you go to an e-commerce website trying to look for options. It's very likely that the e-commerce website that you go to would feel very similar to what you have right now in front of you, right? Some options, not really sort of like very delightful images, very much stock photography, a few filters. You can pick and choose maybe the color. You can slice and dice through different price points. Maybe you can pick the material, right? But then the entire experience is not at all personalized. Even if you order something, it's anybody's guess whether it's going to show up in a couple of days, couple of weeks, or a couple of months. And these days, if you go to any e-commerce website, let's say if you're again in the market for buying a sectional, if you go to maybe restoration hardware's website or some other, then you would be presented with a much more richer view, right? Maybe these websites, these experiences would allow you to upload a picture of your living room so that you can visualize what would that sofa look like in your house. You would have access to many more filters. For example, in this scenario, you can pick and choose. There's a quick ship option that'll ensure that you get your sofa in less than 5 weeks. If, let's say, it's an urgent buy. You can also filter on the firmness of the cushions. And if you look at, let's say, the color options and the price range, everything has sort of like, expanded really greatly. And at the end of the day, if let's say you as a software engineer, if you have to design such an experience, right, it all boils down to a data problem. How can I make sure that I have a lot of rich metadata associated with each of these options? Can I actually integrate with, let's say, my internal inventory management solution so that I can understand whether if, let's say, a customer decides to order this, then to their zip code, can this be delivered in under 5 weeks or not? Does this qualify for a quick ship option or not? You can have, let's say, testers who can go into the field, go into the factories, test your sofa for firmness, and they can tag each of the product with more information about the firmness so that then you can, as a app developer, you can figure out whether sort of like, this sofa is really firm, if it's not quite firm, and sort of like provide those options to the end user. And if, let's say, as an end user, if you run into any issues, then you can click a button right down at the bottom where you can get some sofa salesman on chat who can walk you through what would be some really nice little options for you. But now in this day and age of AI and LLMs, it's very likely that this entire user experience can be thought from the ground up, right? It's likely that if, let's say, we project 2 years out, and it's very, very likely that, maybe such experiences might be available over the next few months, in fact. Maybe the entire filter bar gets replaced by a prompt where you can upload a picture of your living room, and then you can basically have the LLM help you design what would be the right furniture that can sort of like fit that entire setup. Maybe you don't like the furniture that's set up, and you may want a pink sofa, and then the entire experience will basically help you visualize what this pink sofa would look like within your living room. Maybe if you want to try it out and change it with a leather sofa, then all it takes is yet again another search query. And then that search query on the backend will try to figure out what is the right sofa that's available inside your inventory management solution that can actually be shipped to the customer, and you can create that experience right there. If, let's say, as an end user, now if I have to pick and choose all the different elements in this view, and I have to figure out what is it that I want to order, then maybe I click on this lamp and I get this experience which basically calls out that how much is this lamp worth for? How quickly can I get access to it? Maybe there's some rich description that's hyper personalized for me because the application is basically tracking what are my preferences, and it tries to come up with a description that sort of like suits more my preferences. Maybe this is a lamp that's recommended by an influencer. Maybe it's Taylor Swift's favorite lamp, and it would be useful for the company to sort of like call that out to boost their sales. But there's a high likelihood that will sort of like, come across many such user experiences, not only for buying furnitures, but many other products as well in the near future. Now, if let's say as an application developer, if you have to figure out that, okay, what goes into building such an experience, right? From a data science side of the house, from an AI ML perspective, let's just like quickly walk through that. The very first thing that you'll have is some sort of an LLM. So basically a furniture salesman on steroids. You're not really looking for a generic LLM, but you're looking for something that's really sort of like fine-tuned, customized for this purpose, who really understands what constitutes a good furniture and how to really sort of like, address any customer's use cases and not really sort of like, indulge in, let's say, political debates, for example. As a user is clicking through a variety of different objects, there could be yet another component derived from computer vision where you can basically detect objects and map those to your internal inventory. There could be an LLM that's powering the entire description experience. As a matter of fact, when you go to Netflix or any of the other popular streaming services, the description, the synopsis that you see in many cases is generated by these Gen AI models and is hyper-personalized for you so that you really understand why is something being recommended. There could be other recommendation systems in the mix as well. So if, let's say, the system realizes that I'm very much into teen pop and this ends up being something that Taylor Swift really likes, then it would want to really bubble up that fact. Then, of course, this entire user experience is quite visual, so we may employ many different kinds of image generators here as well. There could be personalized discovery in the mix as well. There could be certain specific kinds of furnitures that I might be interested in that the app may have gleaned, and they may want to sort of like surface those ahead of any other pieces that might be in the inventory. And then around that, there would be many other systems that the app developer here would have to integrate with, right? It'll be a really terrible user experience if all the recommendations that I'm shown as an end user are actually out of inventory, right? Or if I have to wait for, let's say, more than 3 months to get access to that. So if, let's say, this entire experience is hooked up into the inventory forecasting system, that would be really helpful. Many times for large pieces of furniture, you have to be really careful about how is this thing actually going to be shipped into my house. Do I have a staircase that will actually fit that furniture, or does it need to be knocked down into other sort of like components? So there is sort of like this logistical optimization process as well that this experience has to basically cater into. And then, of course, every single business wants to maximize their revenue. So you want to really sort of like figure out that the marketing dollars that you're spending, are they actually getting effectively utilized? Is there proper attribution in place? Can you really sort of like figure out that what the ads that you're showing to the users, the corresponding retail activities actually sort of like happening? And that may also sort of like pair into the kind of lifetime value estimates that you may have for any kind of customer to really then sort of like understand what kind of potential upsell opportunities exist. Now, one of the big thing that sort of like, comes up with these systems is that as we sort of like mature up, as these systems start maturing up, it's very likely that not just your e-commerce system, but whether it's your banking application, whether it's your streaming service, whether it's your social network, every single application would be a aggregation of many different machine learning models. These could be generative AI models. These could be predictive ML models. These could be optimizers that have nothing to do with AI or ML that are all sort of like working together to deliver the user experience that will basically make your product excel and differentiate itself from competition. And now as engineers, the problem is sort of like left on us that, okay, how do you basically engineer these systems? How do you actually think about what is the mental model to build these systems? And if you guys have read about the Linux manifesto, right, there's this fellow, Eric Raymond, who has a really nice essay around building cathedrals versus bazaar, right? So in the case of building a cathedral, you can imagine if you have to, let's say, deliver this entire user experience that's composed of multiple different kinds of models, you could basically decide and plan ahead what each of those models are going to look like, how they are going to interact with one another. And this entire planning activity, in fact, can be a rather expensive proposition. It can involve a lot of individuals in a company, and you have to really sort of like take care of every single issue that can arise upfront. At the end of the day, the results can be really gorgeous. The cathedrals, when they are built up, they are massive, they look really nice, they work flawlessly well, as long as the planning and execution is really, really great. But of course, given that these cathedrals are really expensive, you can't really afford to build too many of these. And you would also notice that in many organizations, it's usually sort of like the tentpole project. Let's say in the case of streaming services, it could be recommendation systems. In the case of social networks, many times they're ad targeting platforms would be sort of like built as a cathedral, versus there could be a long tail of many other projects that still sort of like needs to be thought through in that organization. So think about, let's say, Facebook as an example. So you have projects like their ad targeting models that require a lot of forethought, that require really strong platforms to be built out to deliver those really large models. But then at the same time, they have thousands and thousands of different other machine learning activities and projects for which you cannot afford to build a similar kind of platform over and over again. That would just be a very expensive proposition. The other alternative on the other side of the spectrum is that of building a bazaar of sorts. So imagine sort of like a loose collective of folks who are all sort of like aligned on one singular outcome. And you can basically ensure that every team or every project is basically sort of like trying to maximize their value outcome locally. But then it becomes sort of like rather non-trivial to make sure that the end result doesn't end up being Brownian motion of sorts. So the benefit that you get here is that it's actually very quick to start out. You can react to changing conditions very quickly. But then to really sort of like aggregate each and every project together to deliver that end user experience, that end AI ML system can be really, really tricky at times. And then, of course, like there's sort of like a longer term question that, okay, how do you actually maintain these systems in the long term can also start to get sort of like a bit more chaotic. So now, if you're faced with sort of like these two problems that, okay, do we sort of like lean more cathedral style where everything is sort of like platformized and all these projects need to be sort of like really thought through, which doesn't necessarily work in the context of AI and ML, where on almost a daily basis, there are net new innovations that are coming in. If, let's say, OpenAI decides to release a net new model, then many of the efforts that you are invested in may be obsolete almost overnight. Versus on the other side, which is more of sort of like this bazaar style approach where every single team is open to experimenting all by themselves, then your overall coordination cost actually sort of like starts to go up, and it becomes very, very non-trivial to compose a system that is made up of many of these sort of like independent experimental efforts. And an alternative here is sort of like, this somewhat of a form style approach where you can take sort of like the best of both worlds, where you can plan somewhat ahead. You can provide sort of like some opinionated tooling that is common across most of the projects. But then it really sort of like, also fosters a culture of innovation, a culture of experimentation, so that you're able to react rather quickly to results, right? Because at the end of the day, your best machine learning projects, they never end. Once you get something in production, it's only the beginning, actually. It's never the end. So you want to make sure that any kind of tooling that you invest in that basically allows you to continue to iterate over these machine learning projects on an ongoing basis. So the big sort of like fundamental activity to sort of like establish this machine learning farm at the end of the day is the kind of tooling and the nurturing that you're able to provide. Right? Everybody wants to be in this universe, but the unfortunate reality is that unless there is a strong emphasis on the right kind of tooling, the right kind of infrastructure, it can almost always be a pipe dream. Basically, the scenario that we ran into back at Netflix almost 5 years ago, where as a company, we had plenty of projects like recommendation systems, and how do we sort of like, figure out what is the right content that Netflix should be buying or licensing so that it can be then sort of like streamed for its customers. That sort of like were almost built in a very cathedral style. But you can imagine as sort of like the entire sort of like surface area of these projects grew, as it became known that there was a lot quicker innovation that was happening on the open source side, it almost started to become an hindrance, that internal infrastructure. And that basically sort of like pushed us to start thinking about the entire architecture, the entire infrastructure around machine learning in a new light. That what are the real true attributes that are common across sort of like many of these very, very different AI and ML projects that we can provide for a stable surface. And then many of these other teams, then they can basically pick and choose what kind of other tooling they want to use that can potentially sit on top of this. So let's sort of quickly go through an exercise and try to figure out that, okay, what are these common elements that can actually be platformized, right? So one common element for all of these projects always is data. So you would want to make sure that any of the projects that you're working on, of course, the data needs may vary. In certain cases, all you care about is managing prompts. In many other cases, especially if you're fine-tuning a model, if you're pre-training a model, or if you're, let's say, doing classical machine learning, then the data volumes can be rather huge. And what you really need to provide for is access to high-quality data sets in a very cost-efficient and secure manner. Then the next sort of like level up is a question around compute. And of course, that is also oftentimes a spectrum. So you can imagine if, let's say, all you care about is calling into OpenAI Anthropic APIs, then maybe compute is not really that big of a pain point. But if you are experimenting with a variety of different options, if you are trying to fine-tune models internally within your environment, if you're trying to, let's say, train LLMs from scratch, if you're trying to train your own neural networks, then it's likely that you may have non-trivial compute needs. And then a big question that comes up is that oftentimes the data scientists who are tasked with creating these models, creating these training routines, they are oftentimes also not the best place to use cloud compute or the infrastructure that's made available by the cloud. So what is that user experience, that interface that you provide to these folks so that they can be very effective is sort of like, always a big challenge. Then the next big one is around orchestration. So all of these projects, they never exist in a vacuum. They are not isolated islands. It's very likely that your LTV estimate for how much is a customer willing to pay would feed into your causal marketing model. Your inventory forecast would very likely feed into your image generator and your influencer rexes. So how do you basically ensure that the right set of dependencies are set up and tracked is oftentimes sort of like a big pain point for many large enterprises because in this scenario, you are actually sort of like crossing team boundaries as well. We have our favorite problem, which is around versioning, which you can imagine sort of like, a lot of MLOps vendors are also sort of like trying to solve for, where none of these models, none of these approaches are ever stuck in time. They're always, you're always iterating. You have many different versions, so you want to keep track of like what version is running in production, what version is getting iterated on, what version my colleague is running, so that I don't sort of like step over them. So that becomes sort of like, a huge challenge for almost all of these projects, and it can sort of like show up in a variety of different ways. Then, of course, there's the question of deployment. Each of these models have a variety of different needs around how they are deployed. In certain scenarios, if you're relying on an external vendor like OpenAI, maybe you don't really have to care about deployment as much. But if, let's say, you want to deploy a small model on all the cell phone devices, then that's a very different deployment methodology versus, let's say, if you want to deploy a recommendation system model, and then there are concerns around sort of like, how do you think about latency and reliability as well? That becomes sort of like a huge, huge challenge for these organizations. And then at the very top, you sort of like, start to think about modeling related concerns, right? What kind of packages or training frameworks am I using to actually train my models to run, let's say, RAG processes? I may be able to use, let's say, LangChain for my query LLMs, but very likely it wouldn't sort of like, come in handy for my inventory forecasting. So what is that tooling that sort of like is made available to the end user so that they can sort of like get their work done? And now if you look at it from an AI engineer or a data scientist perspective, right, they basically sort of like care about elements that are sort of like at the highest levels of the stack. What kind of modeling frameworks do I have access to? What is the ID or what is the interface against which I'm programming or I'm training my models? How do I actually deploy these models and sort of like make sense of this? Versus when it comes to questions like where is the data actually stored or how do I access compute? In many ways, they would want infrastructure engineers or platform engineers to completely abstract away that problem. I'm yet to meet a data scientist who has had sort of like strong opinions around whether they should be using Kubernetes or not for managing compute. But I've met sort of like every single data scientist that I've met definitely does not want to battle Kubernetes or does not want to battle data warehouses. They just want to make sure that compute is plentiful, cheap, and made available to them very easily. So that's basically what Metaflow, which is an open source project, that we started working back at Netflix basically tries to solve for. It's an opinionated framework that basically tries to provide a solution for all of these different layers of the stack that you can start using today. It's a Python library where you can start annotating your code and you get access to managing data, managing large amounts of compute. You get orchestration by default. Many of your versioning and experimentation management use cases are taken care of. And then you can deploy these models into any arbitrary targets, and you are free to use any kind of modeling framework within that. I know I'm running short on time, so I'll sort of like skip over going into details around how Metaflow works. If you're interested, you can always sort of like visit our blog site, which basically has plenty of examples around how you can sort of like, start creating your RAG-style model deployments, pre-train LLMs, fine-tune LLMs, or sort of like train classical models. Of course, it's not only Netflix that uses Metaflow for training their machine learning models. It's very likely that many of the products that you may have used over the course of day-to-day would have been running Metaflow behind the scenes to power your AI ML-enabled use cases. Very quickly, if you guys want to try this out at home, you can join our Slack community. There are more than 4,000 data scientists and AI engineers who are always sort of like, eager to learn more and share their ideas. The documentation is publicly available at metaflow.org. And if you want to play with the entire setup without worrying about how do you actually deploy, let's say, a data warehouse or sort of like a compute platform, then you can also always jump into metaflow.org/sandbox, which will provide you an entire Kubernetes experience so that you can basically play with all the capabilities of this tool set. Of course, small plug, Out of Bounds is the managed offering behind Metaflow. So if that would be of interest, please do reach out. But yeah, that's pretty much everything I had for today. And we might be on time.
Awesome. I can personally attest to how cool the sandbox is. So do try it out. We have time for one question, maybe. Anybody has questions in the audience? Okay, I have one. So how are you tackling like trying out these large workflows, LLM workflows, when GPU is kind of not available? So how can Metaflow help us tackle some of those problems?
Exactly. So we have sort of like a few different sets of functionality. So one is many times people are bottlenecked on compute on their favorite cloud provider. And it's very likely, I mean, the realities of cloud compute today is that every single cloud provider, big and small, as long as they have compute capacity, they would very actively court rather large customers. And what Metaflow really sort of like allows you to do is move compute transparently from one region to another, from one cloud provider to another cloud provider, even on-prem. And your end user is completely insulated from that movement of compute. So you could have a user who is running, let's say, compute on top of GCP, but for whatever reason, if you cannot get access to GPU instances on GCP, but you have access to GPU compute through CoreWeave, then Metaflow will very transparently move that compute over to those new compute instances. Or if you happen to buy new GPU boxes somehow, and if you have those stashed somewhere, then we can also orchestrate compute there.